So in this video I want to talk a little bit more about converting from decimal to binary. And I kind of ran through the process a little bit in the last video, and I wanted to do one more example before I moved on to the next topic. So let's just take a decimal number. How about, let's see, 18. 18 in base 10, or decimal. We wanted to go to some number in binary, right? Base 2. So let's see. So we start off with our number, and we start dividing by 2, and which is our base that we want to go to. And through a process of division, we get remainders, and those remainders are parts of our binary number in the new number system. So let's do that. So 18 divided by 2, we get 9, and it perfectly goes into it. So our remainder is 0, and that will be what we call the least significant bit of our binary number. And the least significant bit just means it's in the 0 place, right? So if you write a number, so 8 right here is in the ones place, and the 1 here is in the tens place, right? And that has to do with the number system convention of, we have 10 times 10 to the third plus some number, say, let's just take 18. So we have 1 times 10 to the first plus 8 times 10 to the 0. And this turns into 1 times 10 plus 8 times 1, and that's where we get, the name of the place that it's in. So this is the ones place because we're multiplying by 1, and this is the tens place because we're multiplying by 10, right? Okay, so the 0 here goes into the furthest spot to the right, the least significant bit, and a bit is just a binary digit. It's just a condensation of the term binary digit. And so that's our least significant bit. And then we take, now we take our quotient here and we divide by 2, right? So now that's our new divisor, and we divide by 2. So 2 goes into 9 4 times. 8 minus 9 is 1. So now we take the 1 and we put it next to the 0. Then we take 4 and divide by 2 again, and 2 goes into 4 2 times, and we get 0, and that 0 goes out front, and we have 2 divided by 2 goes into it once, and 0, and we have 1 now. So 1 divided by 2, you can't go into it, so it goes into it 0 times, and 1 is the remainder, and now 1 goes out front, and let me see if you can see it, there you go. So now we have the number 10010, right? And that is our number in base 2. That's 18 in base 2. And now a quick example of how to convert from binary back to decimal would be, it's just this process right here, right? So you know your base, which is base 10, which is this guy, and we want to convert this number to base 10. So we have 10010 in base 2. We want to go back to base 10 to confirm, right? So now we just take 1 times 2. In this case, it's 2. Our base that we're in right now, it's in base 2. we want to go back to base 10. So we're using base 2 here. We're using the decimal symbol for 2, right? So plus 0 times 2 plus 0 times 2 plus 1 times 2 plus 0 times 2. And now we can go and fill in the exponents that are supposed to go here. And let's see. So the exponent that goes there will be, so this exponent will be 0, 1, 2. Actually, the 2 is supposed to go on the 2, not the 0. So 2, 3, and 4. So 2 to the 4 is 2 times 2 times 2 times 2, right? So that would be 16. So 1 times 16 plus, these are all 0, plus 1 times 2 to the first, which is just 2. So now we've got 16. We've got 16 plus 2 equals 18, right? In base 10. And now we've confirmed that indeed this number right here matches and converts correctly to this number in base 10. And that's, so this process of going from any other base to base 10, you just whatever base you're in, so this, in this case it's 2, becomes our base here for this formula. And then we just start at 0 for the exponents and then go this way. So we start at the ones place and then we go all the way up, adding 1 each time, and then we convert from exponents to actual numbers. We went from 2 to the 4 to 16 and 2 to the 1 to 2, right? And then we just simply add, and that's how you get your base 10 number.